Welcome to the final module of the Siemens Online Registered Installer Training, Module 6, Installation and Administration. When it comes to proper cabling practices, it's important, and I will reiterate what we've discussed previously, that you don't want to mix components within a channel or a permanent link of a copper cabling system. It's always going to perform to the lowest performing component, so it should be avoided at all cases so as not to degrade the overall performance. As well as fiber components should all be of the same performance. You don't want to be mixing OM1 with OM3 fiber cables within that channel on there, because again, it's not, in some cases, mixing, for example, 62.5 into 50 micron is going to result in significant losses. But even mixing OM3 and OM4 within a system is not recommended, because you're going to lose the benefits of the higher performing system. So if we look at it from a copper perspective, if you install category 5E patch cords and cable and connectivity, you'll have a category 5E or a class D system as it's known within the ISO, International Standards Organization. Category 6 along the way will do that for you. Now, if you install the category 5E patch cords onto category 6 cable and connectivity, you'd have to understand that the overall resulting channel would be a category 5E class D system. So again, anything that's less than the rest of the components in the channel, it's always going to be reduced down to the least performing component. Now, when you're in the telecommunications room, as it relates to the clearance requirements for your racks or cabinets, it's recommended to have a service clearance of no less than 4 feet on the front and backs of those racks as best you can. It's really just designed for access into the room for other equipment and proper safety clearance for managing, whether it be your active equipment, perhaps it's PDUs, perhaps it's installing a new larger piece of equipment. As much as you can get and as much as mandated by local code should be applied. If not, having any of that information is not an option, then 4 feet is recommended to be specified. When installing overhead pathway systems, which is typically going to be a basket tray or ladder rack of some time, it's important to be installed per the manufacturer's instructions. More importantly, it's important to have all sharp edges are removed prior to the installation of cables, as that can have an adverse effect on cables, whether it be copper or fiber cables. You don't want those jackets to become damaged or scored. Finding those problems can be a very difficult and time-consuming process. You want to make sure that the pathways are free and clear of all sharp edges along the way. If you're installing conduits into a telecommunications room, or maybe it's a penetration within a wall coming from outside to inside, it's important that any edges on those conduit systems have a bushing, again, to protect the cables. These cables, you have an investment in the materials as well as the time to install these, and you don't want to see them damaged as a result of not ensuring that the pathways are properly protected from damaging these cables. When installing cable supports, which are typically going to be more of these non-continuous cable supports like a J-hooks in there, it's important that those are located at intervals no more than 5 feet apart, or 1.5 meter apart. And that really just ensures that the cables at the base of the bundle that's in there are properly protected. Now, when you're installing those or any actually telecommunications conveyance systems, it's important to note that you need to support those independently of any other structure or component. So you don't want to be attaching those to something that may move or change over time. So you're thinking about things like the red iron, or using threaded rod or something suspended from the above ceiling to ensure that the pathways are dedicated for telecommunications use only. On this slide, we've highlighted some nice cabling support elements, whether we got some J-hooks or some plastic types of J-hooks, as well as ladder tray and Velcro bundles. So you can see there's nothing here violated. Everything is operated and installed independent of the other systems, are not attached to the ceiling grid or anything like that. On the next slide, we'll show maybe what not to do. Now here you might think some of these examples are a little bit extreme, but it's actually not that uncommon for us to come out to the field to do audits and find situations like this. In some cases, installers, maybe they're running late on the project, maybe they're over budget and didn't want to put in the required supports, but you'll see more of this than you'd like to see perhaps up in the ceiling. It's important to be avoided, because other trades are going to be up there in this space. If they want to move a cable, and if they have tradesmen up there even working on things, they might push your cable out of the way. They might change the pathway for their equipment and then have to take off anything that you might have supported to that. So, believe it, you think it's bad, but the reality of it is it happens more often than it should. So it's definitely something you want to be aware of and ensure that your pathway conveyance systems are installed independent of any of the other systems and are dedicated for their use only. So when installing cables vertically, and those could be cables coming from the ceiling below into a telecommunications room, or perhaps just passing through a telecommunications room going up to a floor above there, it's important that those vertical cables are supported at least twice per floor with proper cable supports. And there's a number of different kinds in the industry. The simplest way to do that is to install some ladder rack or basket tray along that wall and secure them potentially with just Velcro, but there's other clamps that are specifically designed for that purpose as well. So the important thing, and there's always guidelines provided by manufacturers for their pathway systems in terms of how many cables you can fit in there, what's the actual fill ratio of those cables so that it doesn't spill over. But the most important thing to remember is you need to limit the amount of cables in any kind of pathway so that the geometric shape of the cables is not altered. And when you think about that, you think of a very large J-hook or a very large basket tray system. And if you have really, really large bundles in there, you'll notice that the cables on the bottom are the ones that are starting to deform. And most manufacturers do a really good job of kind of rounding those edges and minimizing that level, but you really don't want to see those cables deform. So you want to make sure that you don't overfill them to the point where it changes the geometric shape of the cables. So when it comes to basket tray or cable tray, you really do not, it's an pretty easy calculation, but you want to plan your capacity to be a calculated fill ratio of 50%. And what that will typically result in is an actual fill of close to 100% for the basket tray, because cables don't route as perfectly as shown here in the illustrations. They kind of weave across each other. So if you calculate a 50%, you're probably going to find about 100% fill. Most importantly is, regardless of that, they do have basket trays that have, maybe are 2 inches deep or 4 inches deep or 6 inches deep. And if they are, you don't want to exceed that 6-inch deep maximum fill within the basket tray, because that's usually when you're going to find the deformation of cables on the bottom. Now, if you're installing cables above a suspended ceiling, it's important to have at least a minimum of clearance of 3 inches above that suspended ceiling to allow those ceiling tiles to be able to open up for access into the overall space. And as a reminder, you don't want to exceed that 6 inches of maximum depth. It's going to definitely be unruly and difficult to get into above those drop ceilings as well. In addition to that, you want to have a minimum of clearance of 12 inches above that pathway for the installers to be able to get into those and route the cables, not just fit cables in, but to be able to get their arms in there and to bundle cables and cable management and get their head into there, to work inside. Now, this might seem a little bit basic, but when you're thinking about the cable installation, whether it be copper or fiber, you really need to be installed from the packaging in which they were provided on. So whether you have a reel in a box, or you have Reel-X, or you just have a cable reel, you don't want to take them off boxes or out of that packages and then go to install them. So it's important that you just install them on the original packaging in which they were provided. Now, when it comes to cable bundling, and most manufacturers, or I should say most installers, do a really good job of using Velcro style cables, cable tie wraps, to ensure that the installation is organized and looks good for the end user. The real limitation there is to just ensure, again, you're not deforming any of the cables. And honestly, that's why most people use Velcro cable ties as opposed to plastic ones. Plastic ones can be over tightened and cinch the outside cables, which is not good. Velcro, it's very difficult to over tighten those to the point where you're deforming any of the cable jackets, so it's usually not an issue. And we're going to talk a little bit more about the number of cables in a bundle and why you should be concerned about that as it relates to support of remote powering applications such as Power over Ethernet. So we touched briefly on remote powering applications like Power over Ethernet in Module 1. Here actually is a summary of the 4 different types of PoE levels that are publicly available and something that could be operating on your cabling system over time, ranging from the legacy Type 1, which was released back in 2003, which delivers just over 15 watts at the actual switch. Type 2 was released in 2009, which doubled that to 30 watts and enabled more capability. And both of these were both going over for 2 pairs each. In 2018, when the IEEE released IEEE 802.3 BT standard, they introduced both Type 3 and Type 4, which were 60 60 watts and 90 watts respectively, operating over all 4 pairs. Now you can imagine running with that higher power has some great benefits in terms of some of the applications and devices it can support, but there are also some powering implications you have to be aware of as it relates to bundle sizes and how to manage that cable in the pathways. In 2017, TIA released a technical service bulletin, a TSB, which is kind of an informational standard, if you will. So it's not mandatory, it's just kind of a best practices type of standard. And it talked about mitigation recommendations for managing large bundles of cables as kind of a study. And historically, installers will tend to use larger bundles and really want to manage them well all the way from the work area locations into the telecommunications room. But the reality of it is that you having those cables and bundling them perfectly can have detrimental effects on the cables in the center of those large bundles. So if you're going to, if you have to bundle, and most people are probably going to bundle some level, smaller bundles are definitely recommended. In the example that is kind of illustrated here that they went through, they took a large bundle of cable and they found that by taking a large bundle, and I believe this is about a 90 cable bundle, and reducing it into 3 30 cable bundles, it dissipated the heat on those center cables by approximately 25%. Further, if they separated those bundles by about a 1 inch of space, they reduced the heat in those center cables an additional 30%. So you can see the effects of going from if not separating them, but going from a large bundle to fewer smaller bundles can help. And a good rule of thumb on that is limit the number of cables in your bundle to 24. And you'll see on the next slide why that's important, but it's also a good number because 24 is the typical number of ports that you're going to see on a patch panel. So it's easy to kind of manage that along the pathway anywhere within the telecommunications room or otherwise. And 24 is a number that people work with comfortably in the telecommunications spaces for copper cabling systems. In 2018, TIA also released an addendum to the TIA 569D standard, which has since been incorporated into the 569-E standard. And it was an additional considerations for pathways. It's really just considering pathways if you're going to be doing remote powering. And what this really tells you at the end of the day is that open conveyance systems are much better at dissipating heat than closed systems. So a sealed conduit, an enclosed conduit at both ends is your worst kind of scenario. A standard conduit is slightly better, but a non-continuous pathway, whether it be the J-hooks, do a really good job of dissipating heat because they're so open and the bundle sizes can't be that much. When you look at ladder trays, obviously a wire mesh basket tray type of system is best. A ventilated solid tray is slightly worse, and an unventilated tray is about as bad as you're going to get for an open kind of cabling system. So think J-hooks, think open basket trays if you have the opportunity to specify for your pathways when you're considering the implications for remote powering. Siemens offers a blog, and one of our blogs includes how to manage remote powering of cables, and we provided actually a cable bundling chart, which provides the maximum recommended horizontal cable bundle sizes. And it's a pretty big chart. I don't want you to get too overwhelmed by it, but if you look at the numbers in red we talked about for bundles of 24, it's effectively pretty manageable to do a bundle of 24 for pretty much category 5E and up, as long as your maximum ambient temperature along your cabling channel is no more than 45 degrees Celsius. And it's unlikely it'll get that hot. It can get hot in some of those locations, so it's something to consider. If you need to address that, you kind of larger bundle size, and you need to look at larger diameter cables or larger gauge cables such as category 6A, and also consider shielded cables. If you look at the category 6A shielded and category 7A shielded, they can still support those cable bundles of at least 24 cables all the way up to a maximum ambient environment of 60 degrees C. So something to consider, but as a rule, if your environments don't exceed 45 degrees C, that 24 cable bundle size will serve you well. Another element to consider, and we touched on this with some of the products earlier on, is that if you're going to be installing connectivity in plenum spaces, which are typically going to be above the ceiling for a lot of the IoT devices that you might find, building automation systems, perhaps Wi-Fi systems that are up there, even access control systems, you need to ensure that your cable and your connectivity components are plenum rated. So Siemens offers a number of products such as the Z-Plug, such as our surface mount boxes and our outlets, as well as the cable to ensure that you have solutions for those environments. Now this slide is kind of an informational slide as it relates to cable abatement, and the the reason here, structured cabling should minimize a lot of that, but historically a lot of customers have installed cabling from point A to point B over the years, and the solution to having a new connection is just to run a new cable and not remove any of the existing installed cables. The trouble is, if you look in some of these pathways, they have a significant number of abandoned cables, and it's quite a heat load if there is a fire, not only heat load for fire burning, but also smoke hazards. So, adding new cables over there is not the solution for that. The NEC does require that any abandoned cables are removed or at least tagged on the ends for future use. And you can find, obviously, local authorities having jurisdiction. Those local requirements will supersede any national ones, but most of them have adopted that as well. So if you have a customer who's looking to upgrade their cabling plant, it's good to educate them on that, because it can also be, not only is it something that they need to comply with to remove any legacy cables, but it also provides a revenue opportunity for installers to do that work. So next couple of slides are going to cover proper cable pulling techniques. There's a lot of things that are done, but not necessarily done right. There's some good ideas, practices that'll make your life a lot easier and ensure a proper installation. First and foremost, if you're going to be having an area where you're pulling cables from, you want to secure that area. So ensure people aren't walking through that, aren't stepping out your cables, whether that be with cones, whether it be with tape. It ensures that no one's going to interfere with any of that or damage the cable while it's being pulled or staged to being pulled. Additionally, you want to make sure that the temperature of the environment you have is in compliance with the temperature of the cables being installed. They do have minimum and maximum operating and installation temperatures, and it's important to ensure that those temperatures are in compliance with those products to ensure that those cables will perform properly once installed. Most people will install from the telecommunications room out to the work area, so the cables will originate in the telecommunications room. If you're doing that, you definitely want to pull from just outside the room so that you have access to the pathways and the straightaways that are typically going to be those long hallways and corridors getting out to the work areas, rather than immediately having to turn a corner from the inside of the telecommunications room. You want to position, once you have that identified and established and located, you want to position those reels, either stacking up the reels in boxes or the Reel X, or the reels on your cart for the pull, and staged in the proper direction and stacked. And then when you get to the end of each of these cables, that when you're starting these cable ends for the pull, you want to make sure that you're labeling them properly, at least with a temporary label to identify them uniquely. And then if you have a special cable machine that's going to, and it has any routing spots for those cables to go through, you want to feed those through and ensure that those are all properly managed through there. It'll provide an organized pull for the cables. But you always have to make sure that someone is monitoring those cables during the pull. You can't have one technician just grabbing the cables and pulling them, because you don't know what's happening at the head end. You don't know if one of those reels is close to empty. You don't know if one of them has got stuck or is getting tangled along the way. So it's important to have somebody at that end at all time watching those cables to ensure proper dispensal. So a few other points. After you have all the cables labeled, you want to attach the cables to your pulling string and ensure typically that you have a kind of anti-spin rotation pulling eye on there, so the cables don't try to twist around themselves as you're pulling it. Also, you want to make sure there's more, not just one person back in the telecommunications room, but you want to have people along the way to help distribute that pulling force and inspecting. If you have any cable turns along the pathway, you want to have people helping to manage that and ensuring the cable's not getting damaged as it's being installed. At the end of the day, when you're bringing cable into the telecommunications room for your terminations as well as the work area, make sure you have a little bit of slack in case there are any reterminations that are required. Within the equipment room or the telecommunications room, it's good to have tray around the outside parameter so that the cables are taking just a slightly longer path in case you do need to relocate any equipment or any of those cables along the way. It's kind of built-in cable slack. As it relates to pulling tension, for a standard 4-pair cable, that's about 25 foot-pounds and 50 foot-pounds for a 2 or 4-strand optical fiber cable. It's important to know what the pulling tension is for those cables. You're usually going to find them on product spec sheets to ensure those cable tensions are not exceeded, which can cause the conductors to stretch on fiber as well as copper cables. As it relates to minimum bend radius, under no load conditions for a typical 4-pair twisted pair cables, it shouldn't be less than 4 times the cable diameter unless otherwise noted. There may be exceptions on the product spec sheets. The minimum bend radius under no load for multi-pair cables, so think a 25-pair or 50-pair cable, should be no less than those recommended by the manufacturer. There's a lot of variance there, so there's no rule of thumb for those. The rules of thumb I have seen is 10 to 20 times if it's not known, and that's where you have the next one. If there's no recommendation, at least 10, if not more. Spec sheets are the best one to reference for that from the manufacturer. And we mentioned cable slack earlier, and it's important that slack is available and left at the end of the cable pulls to properly route the cable to its final termination point, to address proper cable management of that, and especially as there sometimes can be re-terminations and relocations along the way at the last minute. You want to make sure you don't have to re-pull an entire additional cable. So it's important to give a little bit of slack at both ends, and where you have it, you want to make sure you manage that slack. You don't want to coil cables up. If you have an additional slack, maybe you want to leave in a basket tray. It's better to do a figure-8 cable than it is to do a cable coil, which can have negative performance effects. So consider that if you have any longer lengths of cable that you need to store slack for. In regards to installation, it's not always about just making sure. Certainly, you want the installation to look good, visually, aesthetically, but that's not really the driving force behind why you want systems to look like this. It's really to ensure proper cable management and routing of cables and support of cables will ensure not only the performance of the system right out of the gate, but just the long-term health of the overall system. So it's important to ensure that your system is organized, managed, supported, and documented accordingly, to give both a good reputation to your installation company, as well as a great experience from the customer from both an appearance as well as a performance perspective. Now, when it comes to installing pre-terminated cables or trunk cables, it's really similar to the many of the points that we talked about for installing standard horizontal cables. The difference here is that you have already factory terminated connectors on the end that you have to protect within the cabling pole of the pathway. Additionally, because those cables already have connectors on the end, the pulling head on those is going to be a little bit larger. So you need to make sure that any pass-through points for the pathway can handle not only the first trunk that's installed there, but the last trunk that's pulled through any opening in the system, based upon its size and how many trunks you're going to have installed. Now, typically, pre-terminated trunks are going to be installed within a data center, which is a little bit of a different space than the typical commercial office building. But you still want to make sure that you're adhering to the pull force requirements of that trunk, and that you're using a pulling eye and a pull string like you would for the horizontal cable. In most cases, trunks aren't going to be significantly long in length. They're typically going down perhaps a row of cabinets, but you want to have a minimum of 2 technicians on there, one monitoring from the reel and one actually doing the pulling. Now, the biggest challenge is actually for trunks is not so much in the installation as much as in the specification for the length of the trunks ordered. So if you have a pre-terminated system, you certainly don't want to fall 6 inches short of your final destination of your panel. You also don't want to be 15 feet long, so you have a lot of slack to store on there. So you need to make sure that you consider the pathways, the entire pathway, in a little bit more detail for point A and point B of those trunks, the horizontal transitions, the vertical transitions, any additional clearance above or below, for example, the cabinets in the data center, is going to be imperative to having a good, clean installation at the end of the day. The final topic we're going to cover here is administration or documentation of your cabling plant. The administration components of a good structured cabling system will have unique identifiers to basically ensure that each cable and each port has an own unique identification point. The actual labeling of the cables, the outlets, the patch panels, etc. within the infrastructure. The record keeping, the ability to understand and document which of those cables goes where using those unique identifiers, as well as the ability to provide reports as needed, usually through a database type of system, drawings of the telecommunications infrastructure, the blueprints, if you will, dating myself a little bit, but the blueprints of your cabling system, identifying where the drops are, where the telecommunications rooms are, and all the details of your telecommunications infrastructure, as well as work orders that may have affected anything that has changed since the original documents have been provided. Now, the components that will need to be properly administered are your horizontal pathways and your horizontal cabling, the backbone pathways and the backbone cabling, as well as the grounding and bonding elements of your telecommunications system, not your whole building, but just the ones specified specifically for telecommunications usage. In addition, your spaces, your entrance facility, your telecommunications rooms, your equipment rooms, etc., and fire stopping locations, even though that's not really a Seaman product, it's important to document that in your system everywhere that you have an opening in the wall for your fire stopping. In the telecommunication spaces, each patch panel port, or if it's a port, could be an IDC block, an S110 block, a 66 block, has to be labeled, and it has to be labeled with a unique link identifier. You don't want the same identifier being used on a different floor, in a different room, in a different patch panel, etc. And that's important to develop that administration system up front day one that defines where that patch panel is located, which patch panel it is, which cable is terminated on it, etc. Everything in the system needs to be uniquely identified. For the cables themselves, each end of the horizontal and the backbone cables has to be labeled within 12 inches of the end of the cable jacket with that unique link identifier, which needs to be visible on that jacket. Even, so if you have it terminated onto a patch panel, you don't want to make sure it's not rotated out of place. You don't want to make sure it's in the wall and then a conduit. It's got to be visible on the exposed part of the cable jacket. So that's going to happen in both in the telecommunications space, like your telecommunications room, as well as the work area and consolidation point if you're using that. In the work area, just like the telecommunications room, each telecommunication outlet should be labeled with a unique link identifier, the same one that's assigned within the telecommunications space. And ensure that it's properly identified and labeled, so if you have a 4-port faceplate, you know which outlet belongs to which identifier. And last but not least, while temporary hand markings are okay during the actual cable installation, the final labeling for all cables and panels should be printed or generated by a mechanical device. That will really speak to the professionalism and quality of the installation. You don't have to rely on interpreting somebody's handwriting, and it doesn't have a professional appearance when it's just handwritten labels at the end of the day. So that concludes Module 6, the final module of our Siemens Online Registered Installer Training. Thank you for your time and attention.